This is AP Calculus AB, looking at the free response question that was released from the 2004 AP Final, question number 6. Consider the differential equation dy over dx equals x squared over times the difference of y and 1, not over, times. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. Well, let's get the ones that are going to equal 0 out of the way, because you generally get 1 point on the free response just for getting those right. If x is 0, doesn't matter what y is, 0 times anything is 0. X is 0 on the y-axis. So slope is 0, slope is 0, slope is 0, slope is 0. This part here, if y is 1, 1 minus 1 is 0. Doesn't matter what x is, 0 times anything is 0. So anytime y is 1, the slope is 0. You would get 1 point for getting the 0 slopes correctly, and you're going to get another point for getting the other slopes correctly. And the rubrics usually read, if they got a positive slope, it's good. If it's a negative, it's good as well. But I'm going to try to make it best to scale that I can, and you should too, because who knows if they change how they grade them from year to year. Well, this is nice, this x is squared. That means if x is positive or negative, it's going to be the same value. So let's say x is positive or negative 1. And let's say we had a y value of 0. That's going to give us 1 times 0 minus 1. That's going to be negative 1. So we're going to have a slope of negative 1 at negative 1, 0, and at positive 1, 0. How about at positive or negative 2? Scratch that. Positive or negative 1, 2. That's going to be 1, and then 2 minus 1. It's going to be 1 times 1, which is 1. Positive 1, positive 1. How about if we got plus or minus 1 and 3 for a y value? It's going to be 1 times 3 minus 1. It's going to be 1 times 2, which is 2, which is more slanty. You get an additional point for all the non-zero slopes. That's worth 2 points total. B, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are positive. Well, something to consider. It doesn't matter what x is as long as it's not 0, because if you square a negative, you get a positive. If you square a positive, you get a positive. So we got to make sure we establish in this answer x can be anything but 0. And then as far as y minus 1 is concerned, we need this to be positive. And this is going to be positive anytime y is bigger than 1. And that's evidenced by me saying if y is y minus 1, we want this to be bigger than 0. We're saying y has to be bigger than 1. So if I combine those answers, I can say the slopes are positive in the xy plane when x is not 0 and y is greater than 1. You would get 1 point for saying that, and this is not part of the answer. C, find a particular solution for f of x equals y to the given differential equation with the initial condition 0, 3. Well, the differential is dy over dx equals the product of x squared and y minus 1. We separate our variables by multiplying both sides by dx and dividing by y minus 1. And then if we integrate both sides, The left side, if we use substitution, u is y minus 1, du over dy equals 1, du equals dy. Be like integrating 1 over u, mad props to u, which is natural log of the absolute value of u, and u is y minus 1. The right side's more straightforward. Add 1 to the exponent multiplied by the reciprocal. At some place we need an arbitrary constant. We typically put it on the same side as the x. Then we use the initial condition. We had the initial condition up here, f of 0 equals 3. So if we put 3 in for y, we're going to get natural log of the absolute value of 2 equals c. So c is a natural log of 2. If we put this together with the equation that we have, we want to solve this for y. This is currently in log form. To change to exponential form, we take the base, which is e, raised to the exponent equals the argument. So that's e to the 1/3 x cubed plus natural log of 2 equals the absolute value of the difference of y and 1. From here, this can be simplified because since this is natural log of 2, we could simplify this and make this e to the 1/3 x cubed times e to the natural log of 2. That's helpful because this here just becomes 2. The reason that becomes 2 is because natural log of 2 is the same thing as log base e of 2, which is asking the question, e to what exponent? No, that's not what that's asking. I'm sorry. I just went off the reservation. E to the natural log of 2 is the same as saying e to the exponent of log base e of 2. We had an identity in pre-calc that says if your base has an exponent that's a logarithm with the same base, it just becomes the argument. It's really not part of our work. So then we got the absolute value by itself. We're going to make two separate equations. We're going to make one where this is negative and one where this is positive. On the left, we get 1 minus 2 e to the 1/3 x cubed. On the right, we get 1 plus 2 e to the 1/3 x cubed. And the question is, which equation contains the ordered pair 0, 3? It's definitely going to be this one on the right. F of x, I'll explain in a moment, equals 1 minus 2 to the 1/3 x cubed. Here's how I know. So we need the y value to be 3, and we need the left side to also equal 3, obviously, for this to be true. If I put 0 in for x, it's going to be 1/3 0 cubed. This whole thing is 0. E to the 0 is 1. 2 times 1 is 2. 1 plus 2 is 3. So 3 equals 3. Over here, if you do the same thing, this is going to be negative 2. 1 minus 2 is negative 1. And then we're saying negative 1 is equal to 3. That doesn't make any sense. So this red answer is our official answer. As far as scoring goes, you get 1 point for getting this correctly. And this isn't written real clear. This is 1/3 x cubed. You get a point for finding c, a point for using the initial condition. You get a point for separating your variables. You get a point for integrating each side correctly. Well, that finishes up 2004 number